Hi, this is Charles C. McGowan with the SolREI Company. This is another presentation on elegant reasonism, part of In Unification's Wake. This is part 4, entitled Unification Implies Relatedness. The standard notice is that this set of charts, along with all of the other ones that we've been doing, are on the website. You can download the charts from the user library off the info tab on the website. You will need to register and then log in, download the PDF charts, bring them up, and then all of the hyperlinks will resolve back to their respective pages in the website. The abstract for this set of charts, essentially, when we historically think about unification, we quest that as a function of usually theoretical astrophysics. But if we back up from that and realize the implications of Langer epistemology errors, and then fold against that systems engineering points of view where there can be multiple logical views of the same physical system, or even multiple physical systems that can achieve the same logical results. And we realize that the way we've been thinking about reality is a logical view. There can be multiple simultaneously logically correct views of the same system. And when we recognize that unification as a concept must be a philosophical predicate priority consideration entering science, it's very profound. We can't get to unification after we're already in science and after we've already made the assumptions that we were dealing with reality, when that is a commission of a Langer epistemology error. We have to recognize what that means, and then we have to back up from that and come at unification outside that trap, because we've been trapped by the Langer epistemology error if we don't do that. When we do that, and we come at unification as a philosophical predicate priority consideration, then we have the necessary elements to build a framework that can deal with that. And that's what elegant reasonism does. And we're able to realize that unification is a tapestry a great deal larger than any single discipline. And until we understand that, you're never going to get to a point where existing status quo thinking can reconcile the issues necessary to perceive unification. And so we have to recognize those issues, and we have to have a framework and an epistemology that are conspire together to reconcile those issues and bring clarity to the discussion. So let's talk about M5 and the source of its relatedness. And it's a misnomer to think that we sat down back in the very beginning, back in 2004, and went down this path thinking that we were going to solve unification. That's just a mistake. We had no desire, no goal. It was not, unification was not anywhere in any of our thinking. That's not what we were looking at. We just stubbed our toe on it and recognized it for what it was after we did it. The origins of the Emergence Model are really steeped in a thought experiment, like Einstein's thought experiments, where we were contemplating something versus nothing. And ultimately, we have to conclude that nothing is irrelevant because it can't influence anything. But that predicates a definition of nothing as dimensionless nothing. We had to eliminate terminology that implied any sort of container There is no container. Any kind of terminology or concept or construct that implies that there might be something on the other side or something beyond that is simply must be eliminated, not just from the language but from the thought processes behind it. And the something then, once nothing is defined in that way, you're required to come back and say, okay, well, that means the somethings that we do have must be capable of manifesting 100% of the phenomena, 100% of the properties that we have on the table, and we have to be able to understand the mechanics behind that to understand how all of this is made manifest. So when we back up and look at MBPs and define the nature such that any individual MBP can entangle or come together with at most 2 other MBPs each, that essentially forms lines. Lines form what in knot theory are called ropes or rope segments. Those things can come together. They can come apart. When they come apart, it's called severance. There's a process for that, and that's when we come to the predominant phrase in the emergence model, that the fundamental entanglement function is limited by severance, and that it is a derivation of the intrinsic nature of MBPs that manifest their inherent character. And because everything real is some configuration of MBPs, means that everything real is subject to those 2 processes, the fundamental entanglement function, and that build process is limited by severance. And when we come to understand that, we understand the limits of these physical configurations and constructs, and we also understand that architectural mass that results from those configurations is frangible under conditions of severance. And that means all real objects under the correct circumstances are frangible. And when we start understanding that and can see it as we go through any given investigation, you'll immediately see the applicability of those things and those relationships, and you'll start to see relationships where you didn't see them before. If we take the MBP as an individual construct and see it as a system in and of itself, so that system enables and empowers the entanglement function, and that it's limited by severance, then we also realize in the same breath that everything real is a system of systems, and that those systems draw their character and traits from the intrinsic nature of MBPs, and they do so without exception. Also, we realize that any MBP or collection of them can be the geometric basis point for all other objects, all real objects in any reference frame. And that's critical and key. Systems engineering. There is a perspective in systems engineering that requirements and descriptions of environments have 2 views. They have a logical view and they have a physical view. And there can be multiples of each view of the same system. And that's important to understand. I know that there is this almost emotional need to want to jump to the physical side of things. And I want to caution everybody from doing that. I've said that in other videos earlier. I'm going to say it again. Probably not going to be the last time I say it either. Logical views are more precise than physical systems, precisely for the reason that there's multiple ways to do any given task and come out with the same logical result. Logical systems have precisely defined inputs and outputs. They have precisely defined results. And There's a lot of different experiments and proof points we could have for those discussions. But here, it's important to just simply recognize the truth of that kind of a environment in order to understand situational thinking required to go across the framework of elegant reasonism. You can have many different physicalities that produce the same logical results or manifestation. You can also have multiple logical views that are supported by the same physical reality, and all may be simultaneously logically correct and true, consistent with nature. But it will also often vary in their degree relative to closure to unification. So, for example, M1, which represents status quo thinking in science today and over the last 100 years or so, it's logically correct, and we've had all kinds of experiments, and people will say that we have empirical data that supports this, and that's all true. But none of that thinking about how we captured that data or how we were interpreting the data that we had, none of that closed to unification. And the more we tried to force that square peg into the round hole, the more elaborate the discussions had to get in order to try to come up with some, and then to the point that a lot of people think that, we're never going to get there. We did get there, but we had to step off of that Mobius loop. Key with the emergence model tools, not the emergence model, but the elegant reasonism tools, is that the tool tiebacks have to be specific, tie back to specific enumerated and iterated encapsulated interpretive models. That's an ISO 9000 QMS requirement, and all of that has to be documented so that we can communicate that to other people and other teams. Critical thinking must guide our procedures to make sure that the requirements and the assessments that we're making are done at the proper control points. And all of these things are common parts of the processes, practices, and methods employed by systems engineering as a profession. And those are, you can look at those on incosi.org. That's INCOSE.org online. Threshold manifestation. What does that mean? What thresholds of relationships and relatedness, as we go from the most simple to the most complex, we must have a framework capable of illustrating and illuminating the relationships at that, I'll call it an order of complexity. So as we move up from the something versus nothing thought experiment, that ultimately led us to the emergence model. And we got there because we were able to label status quo thinking as M1 or M2. That allowed us to add another simultaneously, potentially logically correct model, which ultimately it became the emergence model. Key in that second point is the discontinuous nature of the fundamental entanglement function limited by severance. And it was knot theory that allowed that discontinuous geometric concept to come into its own, really. And it's so powerful that it allows us to see how inorganic matter leads to organic matter. And that's critical, and that's what we mean by the organic architectural mass, i.e. biology. When we look at knot theory and we recognize that entanglement, saturation, and density configurations, we then see that those things are responsible for constructs like dark matter. But, important here is that we have one construct, the MBP. It is the intrinsic nature of the MBP that leads to the fundamental entanglement function limited by severance. It is that nature that leads to knot theory. Knot theory leads to the awareness of saturation and density configurations. That leads to interaction capabilities. It also leads to convergence. And that's when we are able to take in a lot of the constructs from concepts from string theory and bring those into play from that area of science. It also helps us to understand how we can have one definition for energy, and there's not multiple kinds, but we also understand that there's this thing called dark matter that is essentially the same. It's all just matter. It's not dark or light or anything else. It's simply a configuration of MBPs that only interacts in certain ways, and they interact that way as a function of their architecture as configured. It really doesn't mean anything more than that. It's very simple. We talked about convergence, and when we realized that larger orders of complexities, and what I mean by that is more complicated configurations from knot theory, that those more complicated constructs assimilate constituents and they become composites. And when we realize that gravitons are a low order configuration and that they're incorporated into larger orders of composites, we realize that they're a part of everything. And we can have all kinds of discussions about convergence and gravitons and polarity. The convergence from Euler's beta and gamma functions leads us to polar residues. That leads to an awareness that many, if not most, if not all, configurations have some degree of convergence in them, and that leads to an awareness of polarity, not just in terms of charge, but in terms of high mass, low mass. In the case of the graviton, that leads us to the ability to be able to describe the entire universe bang to bang, and understand galactic acceleration and a whole bunch of things from astronomy and cosmology all the way back down through the biological sciences. And in hindsight, it is these thresholds, these threshold manifestations that allow us the ability to focus on different areas of discussion from the simplest construct to the most complex construct. And we can then tie that back out and compare it to what we see in nature, both here locally on the Earth and through the astronomical sciences and physics and those kinds of sciences. So that's what we mean by threshold manifestation. When we look at simplifying, as complicated as all that may sound, elegant reasonism provides a simplification by establishing a framework with processes and methods and a set of tools that support an epistemology. The encapsulation of, for example, status quo thinking, when I say we're talking here in this set of language, and if I'm writing a paragraph down, I'll put a set of parentheses at the beginning of that paragraph and label that M1, and then I'll proceed and say this describes this set of phenomena in terms of how M1 defines the universe. Write another paragraph, put in parentheses M5. This is how M5 describes or makes manifest the same set of circumstances, but does it in M5 terms. And then we can mode shift our thinking between the modes of thought required to do the first paragraph versus modes of thought required to manifest the second paragraph. And so that's that encapsulation of those models in terms of interpretation methods is what we mean by encapsulation. And we have to do that end to end has to be 100% complete. And we also have to be aware that if your thinking is inside M1, you cannot manifest M5. You have to extract yourself from M1 thinking, put it on a blackboard or a whiteboard, write it down, and then put next to it M5, how M5 would do the same thing, and then consider that relative to the paradigms of interest or of nature that you're investigating. That's the only way to do this. You cannot describe one model from the insides of another model, because those models establish fundamental context, and it is the context of all the thinking inside that model. The only way to set that aside is to step out of that model and step back from it. Recognize the Langer epistemology errors in play, recognize the systems engineering requirements that are in play, as well as the different phenomena and properties are discussed. When you're able to do that, it liberates you more than anything I can think of, because it allows you to think about things that you weren't thinking about before. But it also there are many cases where you're constrained by what the interpretive model, how that model behaves, and you'll be in a discussion with a bunch of people in a room, and you'll say, well, we can't do that because nothing can exceed the speed of light. Well, that's true in M1, but it's not true in M5. And so there's a whole series of discussions that you can or cannot have based on that encapsulated view of what it is you're talking about. And this framework allows a simplified way of having those discussions, because now we're able to say, well, that's an M1 point. No, okay, well, over here in M5, we can very quickly refer to and relate to things because of their encapsulation. And that's what we mean by a simplification in terms of being able to talk about something. And again, we define those terms in the tools. In our case, we use our ISO 9001 Unification tool that is built to quality management systems standards, and where all of those definitions are documented, and then they're employed by the different interpretive models. When we do that, we establish a framework and another tool we call the translation matrices, or translation matrices in general. And when we realize that all of that is layered against the objective of unification as a predicate priority, a philosophical predicate priority consideration, then we ask different questions, and we take questions to a different level, a deeper level of understanding. Whereas before we might stop at some layer and stop asking questions. And then we also realize that answers to the standard questions of what, when, where, and how may change depending on whether we're talking about M1 or M5. And when we mode shift those things, we come to an entirely different set of insights. And the example that I would give you is Newton's laws. And I'm not going to go into it here, but I would, ask people to look at that, learn what it means to, M1 is and what M5 is, and then go mode shift the Newton's laws. And you'll see that the answers to what, when, where, why, and how are different for Newton's laws under M1 than they are under M5. And you'll also see that if you ask why something is true, you'll see that the intrinsic definition of M5 is why they are true, where you can't do that under M1. And when you realize that what we used to think of were the answers to the why questions really becomes a description of what is transpiring, not why it's true. And you come away from that with an immensely powerful capability, and that we need to think about and make sure that we're wielding these things responsibly and ethically. And we want the epistemology of elegant reasonism seeks truth as a function of the unified universe. So now we have this capability. Now what? So we can describe these using a basic processes of nature. We can extrapolate them out to include everything else from a physical science point of view, but that's not all of what people contemplate. We also need to recognize that there's a great deal more work to be done. So we need to look into architectures of mass. We need to understand how those manifest physical properties and different phenomena. There's a great deal of R&D we need to do. And we need to conduct specific experiments to ferret out some of that information. Experiments need to be redefined. They need to be reconstituted to make sure that they are taking into account these permutations of architecture. We need a comprehensive systems review of what it is we thought we knew, and then we need to mode shift all of that. So there's a series of bullet points there. I'm not going to read them, but there are a number of activities here that need to transpire. We would love to be a part of those, but we're only a certain number of people. We can't be everywhere and do everything, so we have to depend on you guys to go out and comprehend what the implications of these are and conduct your own systems review. And so we kind of view our job as helping you to understand what it is we've done so that you can then apply it in your own lives and in your own business. We want to do that with certifications and education roadmaps, the website, courses, these videos, etc. So let's talk about how to position all these things. And one way that I typically, one technique I typically use is to try and put them all into the same sentence, to juxtapose them from one another, and that way you come back away from that with an understanding of how something relates to something else that might also be new. So reading it then, elegant reasonism is the framework, e.g. the methods, processes, and tools. So it's elegant reasonism is the framework supporting the epistemology which seeks truth as a function of the unified universe, which produced the first encapsulated interpretive model to close to unification, something we call the Emergence Model, and that it's holistically comprised of both its logical and physical views of M5 and M6 respectively. So the Emergence Model is a product of elegant reasonism. We included it in the patent because the rules of elegant reasonism say that you have to use one of the encapsulated interpretive models that you use must close to unification. Therefore, you must have one. And the first one that we came up with was the Emergence Model. Somebody else may come up with another one at a later date, in which case all this will only serve to refine our insights to a greater degree. It'll only get better from here. Unification is the overarching objective of all elegant reasonism-based investigations, which therein represents a philosophical predicate priority consideration, and I want to reiterate, entering science. You have to have the view of unification before you get into your considerations. If you don't, then the trigger has already been pulled, the trap has fallen, and you succumb to Langer epistemology errors. That's why you must take unification as a philosophical predicate priority before before you go anywhere else. There's a notion that we call the realm of C's. We've talked about that in earlier videos. It's not even linked in this set of charts. If you need to go, you can see that on the website, or you can go look at those other videos for that. It's not intuitive that we're not dealing directly with unification. And people can say, well, we've got all these experiments and we've got all this equipment, et cetera, et cetera, et cetera. One of the traits that humans have, especially as we get into more sophisticated tools, things like computers and maybe aircraft instrumentation, is that we build our assumptions into the very machines and technologies that we use. And if we have abstractions that we assume represent reality, and historically that's where the mistake has been made, then we inculcate those mistakes into our technology. And all it's doing is reporting an affinity for the abstraction that we construed to reflect reality rather than it being actual reality. So we have to have a framework here that's capable of documenting the Langer epistemology errors, understanding the implications of those errors, and how those manifest across the process of recognition, illumination, and analysis as we develop the treatise that is in full compliant alliance and reflects the unified universe. And a lot of that is not intuitive. You have to go through the process and the framework. You have to do the work to fill out the tools and complete all those in order to see where the mistakes have been made. But when you do that, and you are able to mode shift from some concept from M1 to M5, it's powerful. It's just it'll gobsmack you, to use maybe a trite term, but it will. I can't think of another word to the experience is almost ineffable. All right, unification. Historically, I bring this chart up because unification as a concept has a set of requirements associated with it, but the emergence model does as well. And it's important to understand where the requirements are coming from. Are they coming from unification, or are they coming from the emergence model? Because we need to think through those things, because if they're coming from unification and the emergence model does or does not make them manifest, I mean, it may be driving that we need a new model or a better model than the one we came up with. I will say, too, that every time we've gone through that and we've tried to test the emergence model, it only got stronger. And so we're quite proud of the emergence model, but at the same time, we want to recognize that there may be more than one way to think about something. There usually is. So what does unification require? Well, it requires an ability to deploy a common geometric basis point for all real objects. M1 cannot do that. It's not that it cannot do that, it will never do that. Its core constructs are set up in a way that preclude accomplishing that point. And on that basis alone, we can say that M1 will never accomplish unification. I don't care how much money you put into it, or how much effort you put into it. It'll never get there. We want to make sure that reference frames are scale invariant. That means it's the same issues are involved at the smallest scale that they are at the highest scale. And the reason is the small scales are intrinsic to the larger scales. They're in there. They're composites. Those large scale reality, the large scale construct, take the most massive black hole you want, and and take it all the way out to its event horizon and beyond, and the things that are in orbit around it, and you see that the real objects that are there go all the way to the smallest quantum level. And so the universe, the real, actual universe, is unified, whether we think about it that way or not. And so the reference frames must be scale invariant, and they must be isotropic. And isotropic just means it's treated the same way regardless everywhere. You have the same rules, same laws, same everything. And you'll see that the emergence model does in fact do that. The way elegant reasonism works is that all encapsulated interpretive models ultimately reflect the unified universe, but that the actual reality is always held litmus. We want to say that the way we are thinking about this model, whatever model that is, that it reflects the universe. We want to never say this is how the universe is. We don't know that. We're trying to find that out. And because we're trying to find that out, what we want to say is that we have a model. We think it's pretty good. We think it's pretty accurate. Here's what it looks like. And it reflects the universe. And see, here's how we think it works. But go look out the window and make sure that it actually does do that. The real universe is over there. So that's what we mean by that third bullet there. And it's important that the highest ordered constructs have a clear systemic relationship to the lowest ordered detail. And one of the traits or trends of an abstraction, any abstraction, every abstraction, is that the tendency for it is that it insulates and isolates higher ordered ideas from lower ordered detail. And every time you replicate that up the orders of complexity from the simplest to the most complex, there is a tendency to have fate of replication problems with manifesting that lower level detail, that lowest level detail. And so one of the requirements is that those systemic relationships have clarity, and that you can't, that they're evident, you can see them. So unification also means that we have 100% of all properties, phenomena, and real objects must be made manifest. So that means we have to have one definition that comes up with dark matter and regular matter. One definition, not two, but one. Otherwise, you're defeating the purpose for unification. The second to the last bullet is just talking about making sure that we have full compliance across the realm of C's, which we've talked about in earlier videos, and that we're integrating the systems engineering principles, practices, and processes, and that we're employing those in the framework, and that we're engaging the epistemology, the philosophy of knowledge, which means that we're rationalizing and we're justifying what it is we think we know as a function of the unified universe, and that we're doing that as a philosophical predicate priority before we begin science experiments, before we begin to do and discuss science. The emergence model. The elegant reasonism is the framework in epistemology that produced the emergence model, and it just happens to be the first. We hope it's not the last. So holistically, then, the emergence model is both M5 and M6. It's not one or the other. It's both of them. M6 must support M5. It's not until we understand the fundamental entanglement function limited by severance, that we really realize that severance is what is responsible for both the speed of light and for the constancy of time. And we can show that in a number of ways. We'll talk about that in the other set of presentations on the original systems review. Relational concepts that we borrowed from the information technology industry. We borrowed relational concepts from relational databases. Those were really defined by Dr. E.F. Codd, who used to work for IBM. The ISO 9001 unification tool is a relational database. It is not a flat file. It does require clear relationships to be established between the enumerated and iterated encapsulated interpretive models that are employed there. And so it's important to understand that that's what you're doing when you define those things, and that it requires an understanding of those relationships, not simply writing down a definition for a word. The concept of representational state transfer, or REST architecture, is something that really came out for website design. It is a set of criteria that really defines expectations of transactions across the network, the internet, and it also allows us a manner and a method to employ generalizations for areas, but that there are specific means to make manifest those capabilities. And so there's a clear relationship between REST from an IT point of view to REST as implemented. So for example, if we're talking about, well, how does economics manifest because you unify the universe? And then we can come back and take that to human action, make clear relationships with the body of work done by Ludwig von Mises and his economic treatise that he entitled Human Action to the central nervous system and the brain and Brodmann areas and how those work, to synaptic functions, to chemical processes that define how the central nervous system functions and neurons fire and all those things, and take that all the way back and link it over to the periodic table, and then elements and all the way down to MBPs. And we can have that discussion. But REST allows us to do that. These other object-oriented protocols and concepts of class and child and parent, inheritance and layered abstractions, and many more are all traits of the information sciences. They all have become really defined and quantified and codified over the last 50 years or so of the maturing of the information technology industry. It's important to realize that in COSI, the International Committee on Systems Engineering, was really only formed in 1990. It's only been around that long. And so when we start realizing how new this is, it's pretty easy to see why we didn't think about the similarities of those relationships to the requirements of unification, because nobody was thinking. We would use computers to do physics, to study physics. We never thought about the other way around. So this set of charts, I want to emphasize really only barely scratches the surface of all these concepts, and that there's a lot of work that needs to be done, and a lot of exploration needs to be had. And so you can read the rest of this chart yourself, but there's a lot of work left to be done. Okay, in hindsight, I guess we've got two scenarios here. This first one is that once we are starting to be able to paint that larger tapestry, or weave that larger tapestry in those threads, and bring them out to, for example, into economics and philosophy and everything else, and we realize the work that needs to be done, and that has been done, is that don't think that just because the emergence model does close, that it's going to be the only one to ever close. I hope that's not the case at any rate, but in case it is, we offer it, as fodder for everybody to think about. That's why it's part of the patent. Hindsight number 2 deals with the fundamental entanglement function and the fact that it's limited by severance. It makes the point, I think we discussed a lot of this already as well, is that it means that everything real is subject to the same intrinsic nature. And it doesn't matter whether you call that an MVP or you call it some other basic concept, but there has to be a source for all behavior. There has to be an intrinsic nature that's consistent and is responsible for everything. And the emergence model calls that the fundamental, calls the basic real object, most basic particles. Those most basic particles, or MBPs, have an intrinsic nature. That nature can be described with different characteristics. It is that nature and those characteristics that carry through every order of complexity, from the simplest to the most complex, to black holes, to atoms, and everything in between. We have to have a way to show that they have a path to make those things manifest. That path for the emergence model is not theory. And we were able to mode shift concepts like dark matter and virtual particles and prions. And prions is probably a new concept for many people, but it's actually an old term. We can even describe antimatter as simply opposing sets of resonant frequencies which cancel to destruction. And it's perfectly consistent with the emergence model and the way that that's described. And so every time we've come at the emergence model to try and break it, all we really accomplished was a better description of how that phenomena is made manifest, and we are then able to mode shift the concept from M1 to M5. And the insights that come as a result of having done that are powerful. Is the only word I can come to, and I know that it sounds insufficient. It doesn't convey just how epic being able to do this is. MBPs also have 3 states. They have zero energy that does not entangle. They have an entangle capable state, and they have a state that exceeds MBPs, or exceeds severance, and will not entangle because they're above that state. I'm not going to get into that detail here. That's not the reason, but the purpose of putting that here on this chart in this context of this presentation is to show how things can relate to the emergence model, and that the point is that there are mechanisms and means to describe all phenomena, dark matter. We can describe galactic acceleration as a function of graviton pole reversals at distance. We can describe why that occurs, how that occurs. The result of that is that galaxies fly away from each other at an ever faster pace. We can match that up with telescopes and show that that is in fact what's happening out there, etc. And so there are clear relationships here because we were able to accomplish unification, and it only makes our situational awareness of the data that we already have in hand that much more powerful. So object orientation is a concept from the information sciences industry, or information technology industry, and information sciences as a discipline. And in the encapsulation, abstraction, inheritance, and something called polymorphism. You can read these bullets yourself, but I'm going to talk about the polymorphism here because it's essentially a function of higher ordered composite constructs assimilating lower ordered constituents, and that those constituents' character doesn't go away because they got assimilated. It's still there. And so in nature, it would be protons and neutrons are examples where quarks form child classes within the particle that is the neutron or the proton. And if you go and pull up a science book and you look up how much quarks weigh, what their mass is, and then you look up the mass of the proton or neutron, you'll see that the proton and neutron is immensely larger than the sum of the masses of the quarks comprising it. And that delta mass, that delta in the mass, is due to preons. And one of the things that you'll find when you look at those is that the people that study quarks will tell you, well, quarks never exist by themselves. They only exist inside these particles. And it's because they need something to dampen those constructs. The construct that performs that dampening function are the preons, and they hold the quarks in the configurations that result in protons and neutrons. And so that's how those things are made manifest. That's how that object-oriented view integrates concepts of child classes within a larger apparent construct. And that's how we're able to convey those relationships from the emergence model, from the smallest to the biggest. And it's consistent. There's one method. There's one set of processes. There's one cogent description for the emergence model, both for M5 and for M6, and it's on the website. Go register, log in, and take a look at that. So when we look at the configuration taxonomy, you want to know what's the progression here. How do things come together? Some of this we've talked about already. Quantum rotors are when we say a discontinuous configuration, all that really means is that there's subsets. You can think of it like a bill of materials in an accounting system, if you want, where you have multiple parts that come together to comprise a larger component. That could be a brake system, a brake caliper system in an automobile. It could be an engine. It could be a motor. There's lots of different piece parts that go into those larger constructs. And that's kind of what we mean by those things. But anyway, the discontinuous nature allows for the rotor to rotate around an axis, and it can do that at luminal speeds. And that's essentially what a quantum rotor is. I showed in an earlier video a table that talked about orders of complexity from small to large, and made the point even in that other video that that's just an example. the international community needs to come together and decide what needs to be on that in that table. Second bullet we've already talked about, gravitons polarized, high mass, low mass. We talked about dark matter. If you go read the emergence model cogent paragraphs, so we can describe the emergence model essentially in a single paragraph. We have two paragraphs, one for the logical view and one for the physical view. But the point is that there's only one paragraph, and we can make everything manifest from that one paragraph. I think I've made mention of most of this as well. You can read these bullets. Use the comment form, contact us form if you have further questions on that particular chart. M5 span scales. It's important to understand and see the connections from knot theory to the processes, to see how these different things scale and move from the quantum realm to the cosmological realm, and really that it's the discontinuous composite architectures that allow for constituent movement and action within the architectures. And so the point here is that architectures may be intrinsically kinetic, and when we start talking about biological systems, that's obvious, but it's long been sought, how does that come to be? And the answer is the discontinuous configurations of MBPs. We need to understand resonance across those architectures, up to severance for any given construct. That's a whole area of R&D that needs to be done. There's nothing real that's not subject to the fundamental entanglement function limited by severance. Exactly because everything real is a product of these two fundamental processes derived from the intrinsic nature of MBPs. That's a critical sentence. And the other observation that would come out of that is that it necessarily includes black holes. And when we look at when we look at astronomy and we look at nebula coming together and condensing and contraction due to gravity, and we understand that gravitons are a constituent within the composites of larger orders of complexities, real objects, as we move from asteroids to planets to stars, to groups of stars, then to neutron stars, then to black holes that collapse in there. What we really see is a concentration of the gravitons coming into play. And then we start thinking about action as a function of unit area. And black holes simply represent something that rips apart all other architectures, and it eats them. The gravitons pull that material below the event horizon, and the black holes just simply grow. And then they get to the point to where they're so supermassively large, gravitons that are far away from their anchor points at that black hole reverse their polarity, and they repel all other black holes away from it, and then they race off, and then the whole cycle starts all over again. There's a point here on M5 inheritance that, this is how inheritance comes to be in terms of composites assimilating constituents. But one of the real points here that if we look at just knots that have 16 or fewer crossings, and I'll point out that the work has been done to define knots that are over 100 crossings. So this is this point that only there are permutations of knots with only 16 or fewer. Those permutations exceed 3.2 to the 33rd power. That's a huge number. And when we start looking at the knots over 100 crossings, it staggers the mind in terms of the real complexities that may exist in the universe beyond our boundaries. And so we need to really, really back up and think about how these architectures manifest physical properties and the extent to which those are I don't want to say available, I'll say that our perceptions are capable of perceiving. And that, more complex knots only increase the possible potential permutations to a much, much larger number. The rest analogy I think I've already talked about, but it is a network-based programming model whose key abstraction of information is some resource. The analogy being made here is that resource is the MVP, and how it's made manifest is through these layered approaches. I think I've already talked about most of these. Yep. So, trying to summarize here is that we are a part of the universe, and that the universe also exists inside each of us. And that's a powerful, powerful thing to think about. We are all, therefore, related to all of what is, and that relationship is intrinsic. The core constructs allow a basic relatedness between everything real. The cycle of life is evident across all scales in the emergence model, and they're that way bang to bang. Recycling of basic constructs is a function of the same intrinsic nature, and it is inherent in all real objects. The emergence model defines time as an action displacement index, which explains, lots of transformations that are common in empirical experience. The emergence model framework, supporting the epistemology seeking truth as a function of the unified universe, provides a means of measurement that other approaches and traditional things just can't get to. In the next presentation we're going to do in Unification's wake is going to get into some of these insights that we can do because of this awareness here. I'm not going to talk about it in this presentation. It's already long enough. But the point is that elegant reasonism doesn't just illuminate relationships between physical systems and phenomena, but through humanity we are able to see the unified universe in ourselves as well as we of it. The central issue is not really what elegant reasonism can or cannot do. Rather, the issue is what we do because we now have this capability. How do we wield it effectively, and how do we do that ethically? What should we be able to do? What can we do? And how do we treat each other because we can do this and we see these things, and we are able to have insights that can really perceive to this degree of depth. And finally, how will our children pick this up, and what are they going to do with it? And I think that all of this is something that we should hold with great excitement. So that's part 4 of In Unification's Wake. It is hopefully these things have shown how things can be related. And with that, I thank you for your time, and we will see you on the next installment of In Unification's Wake.